Alright, how's it going everybody? So in this video I'll be talking about quadratic patterns. So you might have heard the word quadratic before, and the whole point of this video is just to define quadratic functions in terms of number patterns. And so the two vocabulary words we're really going to need here are quadratic, of course, and rate of change. Okay, so I'll go on to explain what those mean. So before I jump into it, I just wanted to sort of say, quadratic sounds like kind of maybe a very scary sort of math word, but where does that word come from? So in Latin, quad means four. For example, you have a muscle called the quadricep, and there's four parts to that muscle. Or if you speak Spanish, maybe you know the word cuadrado, which means square. And the tie-in here is that quadratic patterns grow like the area of a square. So squares have four sides, quad means four, and quadratic patterns grow like the area of a square. And that's kind of where the language comes from, just from this word four. So let's look at an example then. So here at the top of the screen, I have some squares, because we're going to be looking at quadratic patterns. And if you look at each of these squares, first I have a 1 by 1 square. In figure 2, I have a 2 by 2 square. In figure 3, I have a 3 by 3 square. Now, how do you compute the area there? Well, you can either just count up all these little boxes, right? In figure 2, the 2 by 2 square, there are 4 boxes in the inside. The area is just how much space it takes up. Okay, and or you can multiply, right? 2 times 2 is 4, and 3 times 3 is 9. And in any event, we get these blue numbers here, which are the areas. So first it goes 1, and then it goes 4, and then to 9, and then to 16, and then to 25. We get this little pattern of numbers that come from the area of these squares. So this is a quadratic pattern, and we're going to look at one particular aspect of quadratic patterns, and this is the rate of change, which in this context just means how much does it go up or down by each time. A very simple idea here. So if I look at these blue numbers and I ask how much do they go up or down by each time, we'll notice a pattern. So from 1 to 4, the increase is by 3. From 4 to 9, the increase is by 5. 9 to 16, the increase is by 7. And notice now I record all those numbers here in pink. This is how much that blue pattern goes up by each time. This is called taking the rate of change. Okay, it's just how much it's increasing by each time, how much it changes by. And we'll notice that this pink pattern is actually a linear pattern, right? Because what does it mean to be linear? It means that the pattern increases by the same amount each time, right? So from 3 to 5, the increase is by 2. From 5 to 7, the increase is by 2. 7 to 9, the increase is by 2. And so you see that quadratic patterns, that blue pattern up top, builds off of a linear pattern, okay? And so this is going to be kind of there's a hierarchy here where the quadratics sit on top of the linears. And again, linears, how much do they change by? Well, I've written it down there in green. They change by a constant amount, right? And so you get this sort of ordering. You have quadratics up top. And if you look at how these patterns, these quadratic patterns change, they change by a linear pattern. And how do the linear patterns change? Well, they change constantly. So if you take the rate, here I wrote rate of change times 2. If you take the rate of change and then the rate of change, you get down to this nice constant pattern. And that's what it means to be quadratic. Okay, so quadratics, in our last video we talked about linear patterns, these pink patterns, and now we're building to get more complicated patterns. Quadratics will be able to model more complicated patterns. Okay, and so they build off of linears. All right, and here I have written kind of what I just said. Here's the definition. You know a number pattern is quadratic if its rate of change is linear, right? How do you know if a number pattern is linear? Its rate of change, the amount it goes up or down by each time, is constant. All right, and so that's the main idea of this video. I'll give here a couple examples and then we'll be done. But this is kind of our starting point for our class this year. All right, so here's a quick example. This blue pattern I claim is quadratic. How do you check if it's quadratic? Well, you just look at how much it increases or decreases by each time. So you have this pattern. Maybe when you first look at these numbers, you didn't even notice that there is a pattern to these numbers, but there is. And how do I get that? Well, I say, okay, from 4 to 10, there's an increase of 6. 10 to 18, there's an increase of 8. 18 to 28, there's an increase of 10. And so if I write all of these increases down, it makes its own pattern. Here, 6 to 8 to 10 to 12. And this guy is a linear, right? How do I know that's linear? Because it increases by 2 each time. From 6 to 8, it goes up by 2. 8 to 10 is a jump by 2, and 10 to 12 is a jump by 2. Okay, so again, this makes the original pattern we started with way up here, this blue pattern, quadratic, because its rate of change is linear. Okay, here's another example. Up top I have a quadratic. How do I know it's quadratic? I compute its rate of change. In this case, from 1 to 4 is an increase by 3. From 4 to 10 is an increase by 6. 10 to 19 is an increase by 9. And if I just look at those increases, those numbers in pink there, that's a nice little linear pattern, right? So 3 to 6 to 9 to 12 is linear. How do I know that's linear? Because it increases by 3 each time. Okay, so that's really all we got going on with quadratics. They build off of linear patterns. And as I mentioned a moment ago, we'll see that they can be used to model more complicated things. Okay, in particular, they'll look like areas of squares, as I mentioned in the beginning of the video. Oh, and at last we have a non-example. Okay, so here's something that is not quadratic in blue. How do I know it's not quadratic? Well, I look at how much it increases or decreases by each time. From 1 to 7, it goes up by 6. From 7 to 3, it goes down by 4. From 3 to 10, it goes back up by 7. And so this one is like going up, and then it's going down, and then going up. And so these pink numbers here are not linear, right? Linear would be always going up by the same amount, or always going down by the same amount. And so because the rate of change pattern is not linear, I know that the original pattern is not quadratic. I don't know what type of pattern this is. It's jumping up and down. Who knows what this is? But at least I know it's not quadratic. All right, so in summary, a pattern of numbers is quadratic when its rate of change is linear. And what you should be able to do coming away from this video is be able to identify when a pattern is linear, quadratic, or some other type of pattern. All right, thanks for listening.